This is the title of the quiz. It tells us that we'll be working with Sklearn, a popular Python library for machine learning, and focusing on its scoring metrics. This line introduces the core problem. I need to identify which metrics from a given list are officially supported by Sklearn. The question asks me to choose which metrics are accessible using the _get_scorer_names function in Sklearn. I'll need to know what this function does, and I'll be selecting my answers from a list of options provided below. Option A is the negative mean squared error. It's a measure of how well a regression model predicts. A lower value is better because it means the model's predictions are closer to the actual values. Option B is R-squared, which measures the goodness of fit of a model. It indicates how much of the variance in the data is explained by the model. A value closer to 1 is better. Option C represents accuracy. It measures how often a classification model correctly predicts the class labels. It's a percentage, higher is better. Option D is the logarithmic loss. This is often used for classification models that output probabilities. Lower values are better in this case. This tells me that I can solve the problem using Python code, which might be a practical way to get the answer. This is the Python code to find the answer. It will import the _get_scorer_names function from Sklearn's _metrics module. Use this function to get a list of all available scoring metrics, and then print that list to the console. Then I'll check whether the options A, B, C and D are in the printed list. This quiz focuses on Sklearn, a powerful Python library for machine learning. I'll test your knowledge of the different scoring metrics it offers. Specifically, I want you to identify which metrics are available through a function called _get_scorer_names. This is the core question. I'm asking you to pick from a list of scoring metrics to find the ones that are actually part of Sklearn. This is the negative of the mean squared error. The mean squared error calculates the average of the squares of the differences between predicted and actual values. Sklearn uses the negative version because many optimization algorithms aim to minimize the error, and using the negative transforms the minimization into a maximization. This stands for R-squared, a measure of how well a model fits the data. It represents the proportion of variance in the dependent variable that's predictable from the independent variables. A higher R-squared value usually indicates a better fit. This is a simple and intuitive metric for classification problems. It measures the percentage of correctly classified instances. For example, an accuracy of 0.8 means that the model correctly classified 80% of the data points. Log loss, also called cross-entropy loss, is a measure of how well a model predicts probabilities. It penalizes wrong predictions more heavily when they are very confident, and less when their confidence is low. Lower values of log loss indicate better performance. This is a quiz testing your knowledge of Sklearn, a popular Python library for machine learning. Specifically, I'm testing your awareness of the scoring metrics it offers. Get ready to show off your skills. I'm asking you to identify which metrics are part of the _get_scorer_names function in Sklearn. This function lists all the available scoring metrics. You need to choose all the correct options from the list given below. Think carefully about which metrics you've used before. This option refers to the negative mean squared error. I use the negative because many optimization algorithms minimize functions, and negating the error turns minimization into maximization of a positive metric. This represents the R-squared, a metric showing how well a model fits the data. A higher R-squared value generally indicates a better fit. This is the classification accuracy. It measures how often your model correctly classifies data points. For example, if your model correctly classified 90 out of 100 data points, the accuracy is 90%. Log loss is a metric used in classification, specifically for probability estimations. It penalizes models that make confident but incorrect predictions. A lower log loss indicates better performance. I recommend this approach. It's the most reliable way to find out which metrics Sklearn offers. You'll use the _get_scorer_names function, which returns a list. Then, check your multiple choice options against this list. It's like checking your answers against an answer key. It's super straightforward and avoids any guesswork. If you can't run code, don't worry. You can always check the official scikit-learn documentation. This is the next best thing to running the code. It'll clearly list all available scoring metrics. Think of this as the official guidebook for all things scikit-learn metrics. This shows you the exact Python code to run. I'm importing the function get_scorer_names from Sklearn metrics then running it and printing the result to the console. This list shows every available metric in scikit-learn. You'll use it to compare your options in the quiz. This is a quiz about the different ways we can measure how well a machine learning model performs using the scikit-learn library in Python. Scikit-learn is a powerful tool for building and evaluating models. This quiz focuses on its built-in scoring metrics. This question asks you to identify which metrics you can use directly with scikit-learn's functions like !cross_val_score or !grid search CV. I'll explain each metric later. This is the negative mean squared error. The mean squared error measures the average squared difference between predicted and actual values. Scikit-learn uses the negative version because many optimization algorithms are designed to minimize a function, and minimizing negative mean squared error is the same as maximizing mean squared error, which is not intuitive. This is the R-squared score, also known as the coefficient of determination. It represents the proportion of variance in the dependent variable that is predictable from the independent variables. A higher R-squared value indicates a better fit, ranging from 0 to 1. This is a common metric for classification problems. It calculates the percentage of correctly classified instances. It's simply the number of correct predictions divided by the total number of predictions. This metric is used in classification tasks, particularly when dealing with probabilities. It measures the uncertainty of the model's predictions, penalizing confident incorrect predictions more heavily. A lower log loss indicates better performance. This quiz tests your knowledge of the scoring metrics available in the scikit-learn Python library. I'll be assessing your understanding of which specific metrics are accessible using the get_scorer_names function. Get ready. This is the core question. I'm asking you to identify which of the 4 given options are valid scikit-learn scoring metrics that the get_scorer_names function returns. I'll give you the options below, and you select all the correct ones. It's a multiple-choice question where you might need to select more than one answer. This represents the negative mean squared error. I use the negative because optimization algorithms often minimize functions, making a negative MSE convenient for this purpose. It's essentially a measure of how far off your model's predictions are from the actual values. The smaller it is, in magnitude, since it's negative, the better the model performs. It's a super popular metric. This is the R-squared score. It measures the goodness of fit of a model and how well it explains the variation in the data. A higher R-squared value suggests a better fit. Think of it as the percentage of variance explained by your model. This is classification accuracy. For classification problems, accuracy tells me the percentage of correctly classified data points. I can only use this for classification problems, not regression problems. A higher accuracy means the model makes better predictions. This metric is the logarithmic loss. It measures the performance of a classification model by calculating the log likelihood of the correct class, given the predictions. It usually is used with models that output probabilities. Lower log loss values indicate better performance. It's a common metric for probabilistic classifiers. This section summarizes what I expect you to know and what options are available in scikit-learn's get_scorer_names. All options A, B, C, and D are valid scoring metrics in scikit-learn, which the get_scorer_names function will confirm.